Well, hello there. Sion Batson here from Sion Batson Tutoring, and in this video, we will be working on the quotient rule for exponents. Now, if you are new to my YouTube channel, please click on the subscribe button and turn your notifications on so that you can be notified every time I post a new math tutorial. Thank you. Now, to our exercise. The quotient rule for exponents state when dividing terms that have the same base, we can subtract their exponents. Yes? Very simple rule. When dividing terms that have the same base, we can subtract their exponents. Now, very important. We can only subtract the exponents if the bases are the same. Very important, yes? We can only subtract the exponents if the bases are the same. So far, so good. Now, also, if the terms have coefficients, we will divide the coefficients first, then subtract the exponents. Also, if after subtracting the exponents, we get a negative exponent, we will change that negative exponent to a positive exponent. You should never leave a negative exponent in your answer. So far, so good? All right, now let's go to our first example here. First example, we have x to the fourth power divided by x to the second power. Our base in the first term is x. Our base in the second term is also x. So since our bases are the same, we can subtract the exponents. So we'll first put our base back, x, and then we will subtract 4 and 2. And if we subtract 4 and 2, we will get 2. And we're done. Very simple concept, very fun concept. Note how the base stays the same. We do not touch the base. We only subtract the exponents. Get the idea? Perfect. Perfect. All right. All right. Let's try another one here. Very simple concept. Fun, simple concept. Let's try x to the 10th power divided by x to the 7th power. Yes? So first, we will check our bases. Yes? Well, our base in the first term is x. And our base in the second term is x as well. So since our bases are the same, we can subtract the exponents. So we'll put our base first and then subtract the exponents. Now, when subtracting the exponents, the exponent in the numerator always go first. Yes? When subtracting the exponents in the numerator or the exponent at the top always go first. So we put our 10 first and then the 7. So we'll subtract and we get x to the third power. Very simple, very fun, straightforward. So far, so good. All right, look at this. I know that you guys already have this down because you guys are smart, right? So what I'm going to do now, I am going to give you guys a chance to try one. I know that you guys already have this concept down. And I know that you guys want to prove to your parents and your uncle or your aunt or your grandparent that you have this down. Yes? So I'm going to give you a chance to give it a try. Now, if you need to, you can go back and watch the previous examples and then come back. Okay? Pause the video, give it a try. All right, welcome back. Let's see if we will get the same answer here. Now, first, we see our bases are the same. So since the bases are the same, we can subtract the exponents. So we will first put our base back, x, and then we'll subtract 5, take 3. And if we subtract, we get x to the second power. And we're done. Very good. Give yourself a tap on your shoulder. Very good. Very good. Now, if you made an error, don't be upset. Just find your error, correct it, yes, and work the problem again. Make sure you have this concept down. All right. Let's make these problems a little more fancy. Yes, they are too plain. Let's make them a little more fancy. Let's say we have 20y to the, let's say, 9th power divided by, let's say, 5y to the, let's say, 4th power. Now, our terms in this example have coefficients. Remember what the rule says, yes? If our terms have coefficients, we will divide the coefficients first. So the coefficient in the first term is 20, and the coefficient in the second term is 5. So we will divide 20 and 5. 20 divided by 5 will give us 4. So we'll put our new coefficient, 4. Now, let's check the bases. The base in the first term is y. The base in the second term is y as well. So the bases are the same. Since the bases are the same, we can subtract the exponents. We can subtract 9 and 4. So we will first put back our base, and then we'll subtract 9 and 4. Yes? After subtracting, we will get what? 4y. 9 take 4 is 5. 4y to the 5th power. Very simple, very fun, very exciting, very straightforward. Yes? All right. Now, I'm going to give you guys a chance here to try one, because I know you guys are always looking for the opportunity to flex your muscles, yeah? And show how smart you are. All right? So I'm going to give you guys a chance to try this example. Yes, again, if you need to, you can go back and watch the previous examples. When you feel as though you have it down, come back and try it. But I want you to pause the video and give this a try. Go ahead. All right, welcome back, my friends. Let's see if we will get the same answer here. So first, our terms have coefficients. The coefficient in the numerator is 12. The coefficient in the denominator is 6. So we will divide. Now again, when we're dividing, the coefficient at the top will go first. So we divide 12 divided by 6. That will give us 2. So we'll put our 2. Let's check our bases now. Well, the base in the numerator is y, and the base in the denominator is also y. So our bases are the same. So we can subtract the exponents. And remember, when subtracting, the exponent in the numerator always go first. Sorry, why am I forgetting the base? Put the base back. Yes, put the base back. Then subtract. Always put the base before you subtract. All right? And again, the numerator at the top always go first. So far, so good? Great. So after subtracting, we'll have what? 2y to the 9th power. Because 13 take 4 is 9. Very simple, yes? Now, even if you made an error somewhere along the process, don't get upset. We all make errors. We all make errors, yes? Find the mistake, correct it, and try the problem again. You are smart. You got this. You can do this. This is simple stuff, okay? I've been doing this stuff since I was in kindergarten. That's a lie. All right. Now, let's say we have now x to the negative 7th power divided by x to the let's say 3rd power. Now we have a negative exponent in our picture. So let's see what's going to happen. So first, our base in the first term is x. Our base in the second term is also x. So our bases are the same. Since our bases are the same, we can subtract the exponents. So we'll put our base back first, and then we'll subtract -7 minus 3. And this will give us what? X to the -10th power. We have a negative exponent in our answer. And remember, you should never leave a negative exponent in your answer. So we will make this exponent positive. Now, if you need to review how to make a negative exponent positive, no trouble, go check my video out, changing negative exponents to positive exponents. When you feel you have mastered the concept, you can come back and join me. All right, let's go. So we know that to make a negative exponent positive, we will move the negative exponent and the term attached to it, yes? To make a negative exponent positive, we will move the negative exponent and the term attached to it. Now, just as a reminder, remember x to the -10th power is the same as 1x to the -10th power, or 1 times x to the -10th power. So this -10 is only attached to the x. So we'll move the -10 and the x to the denominator, because everything right now is in the numerator. So it's just a move. It just takes a move to make the exponent positive. So if we move x and a -10 to the denominator, what will we have left? We'll have 1 left in the numerator and x to the 10th power. And we're done. Now again, if you need to review, if you need to spend some time reviewing how to change a negative exponent to a positive exponent, please go watch that video. It's very clear, it's very fun, and it's a very simple concept. Okay, now, let us continue, my friends. You know what? I'm going to give you guys a chance to try one, because you guys are just sitting there watching me, being entertained. So let's try one here. Let's try 15a to the -12th power divided by 3a to the, let's say, 4th power. I want you guys to give this one a try. Pause the video and give it a try. If you need to, you can always go back and watch the previous examples, then come back and try it. But I need you to pause the video and give it a try. I believe in you. All right, welcome back. Let's see if we will get the same answer. So first, our terms have coefficients. The coefficient in the first term is 15. The coefficient in the second term is 3. So we will first divide our coefficients. 15 divided by 3 will give us 5. So we'll put our 5 back right here. Now, let's look at our bases. The base in the first term is a. The base in the second term is also a. So our bases are the same. Since our bases are the same, we can subtract the exponents. So we subtract, we'll do -12 minus 4. Sorry, again, I keep forgetting the base. Why is that? All right, so we'll put now -12 minus 4. We can't forget the base. We must put the base back. After dividing, don't forget, like me, to put the base back. You must put back the base. All right. So what's left? After subtracting, we'll get what? 5a to the -16th power. But again, we cannot leave a negative exponent in our answer. So what are we going to do? We must make it positive. And to make it positive, we will simply move the negative exponent and the term that it's attached to. That's it. In this example, the -16 is attached only to the a. Yes? So we'll move a and -16 to the denominator. So after the move, what are we going to have? We're going to have 5 over a to the 16th power. And I know you guys got that. Very good. I'm very proud of you here. Give yourself a tap on the shoulder. Very good, very good. Now, again, if you made an error somewhere, like I did by when I forgot the a, it's fine, right? Find the error, correct it, and try the problem again. We all make errors. I just proved that, right? We all make errors. That's a part of learning, yes? Don't be upset. Find the error, correct it, and try the problem again just to make sure you have the concept down. All right. Let's try one or two more. Let us try, let's say we have x to the negative 7 divided by x to the negative 9. Ah, two negatives. You guys want to give it a try? Really? Very nice. I am so proud of you. I'm going to give you a quick minute to give it a try and then come back and let's see if we get the same answer. Okay? All right, welcome back. Let's see if we get the same answer here. First, our bases are the same. So we'll first put our base back. And since the bases are the same, we can subtract. So look what happens here. Pay attention now. We put the first exponent, which is negative 7. And then we put the subtraction sign because we have to subtract these two exponents. Students often forget to put the subtraction sign, especially when the second exponent has a subtraction sign or a negative sign in front of it. But you cannot forget to put this subtraction sign back first. Then we put the second exponent. See that? So what are we really left with? If we combine the signs, we're really left with x to the negative 7 plus 9. Yes? So this will give us x to the second power. I know some of you forgot to put this subtraction sign back. That's fine. That is why I chose this example, just to prove a point here. Yes? Again, if you made an error, no problem. Don't stress. You can always go back, find your error, correct it. Yes? And then try the problem again. All right. Now, let's do one more. Let's do one more and I'm out of here. Let's say we have, let's choose another variable. I know you guys are tired of seeing x. Let's choose b. B to the, let's say, negative 8th power divided by b to the, let's say, negative 8th power. Let's try this one right here and see what happens. So again, our bases are the same. So we put our b back. And since the bases are the same, we can subtract the exponents. So it will be negative 8. And again, we'll do what? Before you put the second exponent, put your subtraction sign. Don't forget that. Always put the subtraction sign before you put the second exponent. And the second exponent is negative 8. So this will give us what? B to the negative 8 plus 8, which is b to the 0 power. Because negative 8 plus 8 is 0. Now, the 0 exponent rule says any value raised to the 0 power is equal to 1. Yes? Any value raised to the 0 power is equal to 1. So b to the 0 power is equal to 1. I just wanted to talk about this rule. That's why I gave the example. How was that? Very useful, yes? Very simple, yes? All right. I really hope you guys enjoyed this video. I really hope that you guys will find it helpful and useful. Yes? Again, if you're new to my channel, please click on that subscribe button and turn your notifications on so you can be notified every time I post a new math tutorial. A new, fun, and exciting math tutorial. Now, until next time, I need you guys to practice, 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 and enjoy your math homework. See you.